We are on. Let's see if we can get that going. All right, what we're gonna do, we're gonna convert the tablet one time, so all right, I guess it's fine. These books can come a little closer to me. Okay. Right, so all right, guys, so a couple of you guys requested, so somebody mentioned log, somebody said APGP, somebody said equation of a circle. So what I did is I pulled all the question twos. So let's see how fast we can get through these question twos, specifically with reference to the APGP stuff, because I know there were a couple of years where it was a bit challenging, and I want to make sure that we prep for whatever they could bring, or at least we prep based on what they've brought before. All right, hey Stefan, cool. Yeah, it seems like I get through there, so let's hope it holds out, right? If it 6 again, I might have to disconnect for the rest of the afternoon more, but let's just hope for the best. Yes. Okay, so this is from the specimen paper. All right, like I said, we're going to focus specifically here. If anything, we could also round back and touch on some completely square stuff if you all feel you need to do so, or the inequalities. We also have some alpha and beta things here. I know some of us might be a little rusty on, so I want to, like I said, I want to try and touch on everything. Okay, how you all feeling now with the tricks? A little better, right? I also had to send in that video with the stuff that we did, so you can just go it over, right? Those on the live, thanks for joining. Quality a little bad. So if you could say the yeah, I had to adjust the output bit rate, boy Stefan, for this to even stream at all, to be honest. So yeah, but see if you could, in the settings, see if you could adjust the resolution quality, apart from auto. See if you get like 240, 360, see if you get 720. I have mine on 720 laptop here. Alright guys, so first thing to do is we're going to take a read of the question, right? So given the series, I have one of two. Actually, you know what we want to do first? Let's just take a brief revision of the formula that we would need in order to be able to tackle APGP questions. How about that? Sound like a plan? Alright, just going to zoom out this one for a little bit. Alright, so an arithmetic progression or arithmetic sequence, also shortened to an AP, right, is one where we have a sequence of terms, and the terms progress based on a particular pattern. So let's say, for example, we had 2, 4, 6, 8, 10, ... Right? So we could see how this pattern advances. Right? We have to add, right, what? How much? We have to add 2 every time we increase, right? Now, this 2 here is referred to as D, which is the common difference, all right? Oops, all right, let's try to write a little neatly today. So common difference, all right? And this one here, this is notated as A, which is the first term, all right? And the thing for the first term, normally they say, well, T for term and T1 is first term, right? I know some people have some flashback from the maths exam, the sequence question 7, right? But I hope you all were able to deal with at least part A. I think part A should have been okay. Part B was, anybody heard of Fibonacci's sequence, Fibonacci's progression? No? Yeah, you heard of it? All right, cool. But in any case, it's gone already, right? And according to what the ministry and CXE pronounce, you may have to do it over, but I'm not gonna fuel any rumors. We know nothing as at this point in time. Right, so don't worry about it, focus on what you have to do, and if and when they say something about it, then we'll talk about that. Alright, now, going from there, so T1 is that. Now, the formula to find any given term in an AP. Anybody know it offhand? Alright, so you take the first term, and you have to add some multiple of D, because if we keep adding 2, right? So, if you keep adding the same number over and over, eventually it's basically you're adding multiples of that number, consecutive multiples if you're going straight in order. And the multiple you have to add is always 1 less than whichever term you're looking at. So for example, let's say you want to define term 3. This would be equal to A plus 3 minus 1 by D. What's 3 minus 1? 2, right? So this would be equal to A plus 2D. Right? Let's say you want to define the 7th term. This would be equal to A plus 7 minus 1 by D. Right? Now normally of course I'll go into more detail and show you the pattern of how to derive, but I mean we've done that, we've been there, exam is Tuesday, let's just get to the point, right? So A plus 6D. Okay, so they can ask us to find the nth term, any specific term. They can also ask us to find an equation specific to an AP for the nth term. And the example I want to do, okay, so Zelia, give me any number between let's say minus 5 and positive 5, any number. Alright, so A is equal to 4. And Skylar, give me any number between minus 5 and positive 5. 3. Okay, so 3. Right, so here, if we want to find a formula or an equation for the nth term for this specific AP, we use A plus n minus 1 by d, and we substitute in the values of A and d, being 4 and 3 respectively. We'll use distributive law to expand the bracket to the back here, so we have 4 plus 3 by n minus 1. Sorry, I was supposed to expand it, right? So 3 by n is 3n, 3 by minus 1 is minus 3. And what's 4 minus 3? That's 1, right? So 3n plus 1. So you can use this specific formula to find the nth term for the AP defined by a first term of 4 and a common difference of 3, right? Let's check it out. So we know the first term is 4, right? So if you wanted to find T1 using this same formula here, you would put 3 multiplied by 1 plus 1. What's 3 by 1? 3. And what's 3 plus 1? That's 4. We know the second term will be 4 plus 3, which would be what? 4 plus 3 is 7, right? If we double check with the formula, we'll do 3 by 2 plus 1. What's 3 by 2? 3 by 2 is 6, and 6 plus 1 is 7. So we can use the generic formula for the nth term of an AP in conjunction with, sorry, I erased something there, in conjunction with the parameters of that AP, the parameters of the definition being the first term and the common difference, substituted inside of the formula in order to find, like I said, an equation specific to that AP for the nth term. Are we okay with that? All right, so that's one thing. The next thing we want to talk about is the sum. The name of this topic is sequences and series. A series is the sum of the terms in a sequence. All right, so the sum of the first n terms of an AP right now, this formula Sn is simply, now you have two versions of it, n over 2 multiplied by A plus L, where L is the last term. Right now, the thing is, a lot of APs are infinite progressions, in which case you will never have a last term. But let's say you wanted to find the sum of the first 10 terms. In that case, what you've done is you've created a last term to which to go. And to find that last term, we could simply use this same formula. So essentially what happens is that formula is substituted in place of L. And what happens is when you combine, when you substitute and you simplify, right, we get the following formula. N over 2 multiplied, sorry, let me fix that a little bit. N over 2 multiplied by 2A plus n minus 1 by d. Alright. Zaire, we all failed math. Alright, well Zaire, I hope not, honestly. Right? I think you all may have done better than you thought. Right? Sometimes those questions tend to throw us and we get very emotional and confused in the exam. That happens. Right? But anyhow, let's hope for the best, alright? Okay, so we have two formulas which to use. Now, can we do the same thing for the sum of n term, the first n terms, as in find a formula specific to that particular AP? The answer is yes, we can. All right. So if, for example, okay, so sorry, Kyron, pick any random term between -5 and 5 inclusive. 4. Oh, we picked 4 just now. Yeah, sorry. Or -4. All right, cool. So let's say A was equal to -4. Right, and I will pick 1. So let's say D was equal to 2. All right. So what we could do if we had to find, all right, Sharida, good afternoon. How are you doing? If we had to find a formula specific to this AP for the sum of the first n terms, we could substitute. So let's do Sn, sum of n terms, n over 2 multiplied by 2A plus n minus 1 by d. Now what we're going to do is we're going to substitute these values here to get that particular. So n over 2 multiplied by 2 by -4 plus n minus 1 by 2. Close that bracket. Scroll up a little bit. Right, so on the outside we have the same n over 2. Good. How about me? I good. I had a good lunch, so I ready to go. This will be itis do kicking hard, right? Using distributive law, 2 by n will give us 2n, and 2 by minus 2 is, of course, minus 2. Sorry, square bracket. Yeah, the Americans call this a parenthesis, and this a bracket. All right. Not that that has anything to do with anything, but just in case. Of course, minus 8 minus 2 will combine to what? Minus 10. Very good. So we have 2n minus 10. And then this n over 2, right? If you multiply that by the inside, then what's going to happen? 2n by n over 2, right? 2n by, that will give us what? So we get 2n squared all over 2 minus 10n over 2. When you simplify, all right, do disguise quadratics, please. All right, Julia, I'll see what I could. If not today, Monday. All right, so we could cancel the 2 here. We will get n squared. All right, 2 and that goes 5 times, right? 5n. So here we can get a formula for the sum of the first n terms. And of course, what type of equation is this or function is that? Quadratic. Not so? It's just a quadratic without a constant, right? Interestingly enough. All right. Okay, so that's a little revision for APs. All right. What I'm going to do as well, let's revise GPs one time. All right, so that was, sorry, I know I was scrolling fast with some of you guys, so sorry if you guys joined late. The live was sticking the past couple of days, so I know y'all might not have wanted to quote unquote waste your time. I don't blame you. All right, so let's go. So let's revise GPs now. All right, so geometric progression, right? So a geometric progression, whoa, wait, oh, and all of a sudden the line disappeared, right? Now that's a term, that is a sequence of terms, but instead of progressing via addition, right? Do differentiation, chain rule, quotient rule, product rule. Anybody need to revise differentiation? You know? All right, I'll see what I can do. I can't promise anything. All right, okay, so a GP is a sequence of terms that progresses via multiplying. So let's say, all right, give me a number between 1 and 5. 2. All right, give me my next number. 4. All right, okay, give me an odd number. Sorry. 3. Okay, so let's say we had 2. Then we had 6, then we had 18, then we had 54, etc. Right? So of course, 2 plus 4 is 6, but 6 plus 12 is 18, 18 plus 36 is 54. So we are not progressing here by addition. We are progressing here via multiplication. Right? And it's not only integers by which we can multiply, right? For example, if we simply reversed this sequence, if we did 54, then we did 18, then we did 6, then we did 2, here we'd be dividing by 3, and dividing by 3 is equivalent to multiplying by 1/3. So that is how a GP progresses. All right. Liam, Chris, was it today we could come and study or another day? You could come study any day once you message me, and I confirm you could come. All right? I'm not working tomorrow, so you can't come tomorrow. Sorry. Liam, I didn't mean coming now. Hi, Liam. Yeah, I saw the message, but I just responded to you. Yeah, it wasn't, you had a comment. When I say, you had a message me or comment before, and I could confirm when and when you could come. Yeah, no problems. Yeah, cool, later. Great, all right. I don't know, I think I'm supposed to be doing POB, I think Tuesday. All right, sorry, those on the live, just give me a second, let me, on my backup, I seem to be, I'm not even sure, my face on the screen, let's transition to that, and then let's put back here, okay, wave, all right, transition back. All right, okay guys, sorry about that. Right, so like I was saying, you can multiply by fractions, and of course it could be negative, right? So with this type of progression, that's called a converging geometric progression, because the terms get smaller and smaller as the further on we go. This one is called a divergent, right? Divergent sequence or diverging sequence. You have to fix that capital D, right? Divergent. This is convergent. All right. So our formula is here. The nth term of a GP is a by r to the n minus 1. So we're seeing where we are raising to power. So this is an exponentially increased or progressing sequence. All right. So we're going to do, all right, so example 1. Let's do a first term equal to, let's say 3, and let's take a r of 2. So I just reverse a couple of things. Instead of the first term being 2, right, so we're going to do that. So the, not d, sorry, r is equal to 2. Right, so the nth term here, let's say we want to define term 7. This would be a multiple, sorry, a is not 2, a is 3. Okay, great. It's embarrassing, right? 2, and we want to define the 7th term, so that's 7 minus 1. So that's 3 multiplied by 2 to the power 6. Anybody know what 2 to the power 6 offhand is? What's 2 cubed? 8. And what's 2 cubed by 2 cubed? 2 to the power 6. So what's 8 by 8? 64. Alright, so you get 192. Alright, let's take one with a fraction. So let's say a here was equal to, let's say 16, and r is equal to half. Let's say we want to define t. Okay, somebody give me a number between 6 and 10. 9. Let's say we want to define the 9th term. So that's a, right, sorry, which is 16 multiplied by a half to the power 9 minus 1. That's 16 by a half to the power 8. So what's 2 to the power 8? What's 2 to the 4? Well, 2 to the 4 is 16. And it'll be 16 by 16, which is... Oh, we don't have to worry, because look at it. We could do 1 over 16 by 1 over 16, right? What will happen? This will cancel with that, leaving us with 1 over 16, right? So you don't always have to work out stuff in your head or run to your calculator. You can expand things, right? It's kind of looking in amazement. Your brow's on fleek. You went to the morning to them out. Just chilling. All right, cool. All right. Now, can we also find a formula for the nth term specific to a GP? The answer is yes. All right. Let's use this same one on top of here. All right. So if Tn is equal to a by r to the n minus 1, we could do 3 by 2 to the power n minus 1. Now, laws of indices. Under what conditions do we subtract indices? When you're dividing, when you have the same base and you're dividing, right? So 3 to the power 2n minus 1 could be the same as 2 to the power n minus 1 could be the same as 2 to the power n divided by 2 to the power 1, not so? So this could be 3 multiplied by 2 to the n over 2. So you could even treat it like this, 3 over 2 by 2 to the power n. Let's see if that holds, right? So we found the 7th term up here as what, 192? All right, so let's see if it works. So if we want to find T7, which would be 3 over 2 multiplied by 2 to the power 7. 2 to the power 7 is 128, right? No? Yeah, maybe? So you have 3 over 2 multiplied by 128. 2 into 128 goes 64 times. And 3 by 64 is 192. So yes, so it could work. Alright, so that's the nth term of a GP. Alright, let's go again. Let's talk about the sum of the first n terms of a GP. Alright, now the derivation of this was actually, I found it really elegant, it was genius in my opinion. Right? If you'll never study derivation, if you have the yellow and green book, go in this chapter and read that derivation. Hopefully you understand it. Anyhow, we have, they say we have two versions of this. One is a multiplied by 1 minus r to the n all over 1 minus r. Or you have a by r to the n minus 1 all over r minus 1. Honestly, it doesn't matter which version you use because you're going to get the same answer, right? Some people say this one is used when r is between 1 and minus 1, and this one is used when r is less than minus 1 and when r is greater than 1. Right? Because there are two values which it doesn't make sense to have an r for, right? 1 and 0. Because if you have a value of r equal to 1, every successive term in the GP will just be the same as the first term, right? And if you have an R of 0, you're only going to have a non-zero first term and then zeros the rest of it. So those sequences don't make sense. All right, so it's saying stream health is poor, boy. Sorry about that. All right, now, where was I? What was I saying? Okay, but like I was saying, honestly, it doesn't make a difference which one you use, because basically how you get one from the other is you factorize with minus 1. So like here, if you, like a weird cube, right? If you pull out minus 1 as a factor here, you get minus 1 plus r to the n. If you pull out minus 1 as a factor below as well, you get minus 1 plus r. And of course, minus 1 could cancel with minus 1, not so? So then you'd have r to the n minus 1 at the top and r minus 1 below, which is the same as that. Alright, so it really doesn't matter which one you use. Okay, and the last thing I want to review before we go on to the past paper questions is the sum to infinity. Now, once again, let's just clear this up. The sum to infinity is not the sum of an infinite number of terms. The sum to infinity is a value that a series approaches as it goes on, as it continues, right? So as n tends to infinity, as n continues to get larger and larger, as the series continues on, the sum of that sequence will approach a value we'll never reach. And that is simply given by a over 1 minus r. And it only works for where r is between 1 and negative 1, where r is a fraction, right? If you think back up to the top, I was talking about where r is, where you have convergent and divergent sequences. It only works for convergent sequences, right? Because those terms get smaller and smaller and smaller. If the terms are getting bigger and bigger and bigger, you have a divergent sequence, it will never approach a particular value, right? So a sum to infinity is not the sum of an infinite number of terms. It is a value to which a series approaches but never reaches. All right, okay. So that's the basic recap. We also have some sigma notation stuff, but let me come back to that. I think I want to jump into the questions at this point in time to get your feet wet, and then we will go from there. All right, so we're going back here. All right, so we're approaching the questions in order from 2011 to 2018. We're going to focus specifically on the AP GP questions, and then what we will do is we will double back, and anybody else, actually, we will work the, alpha beta questions, inequality questions, complete and square questions. All right, I want to approach it in that order, because I think most of us might be okay with complete and square from maths. We might not have to rush back to it. If that's an incorrect assumption on my part, please let me know. If you want that as a priority, I'm very happy to do so. If not, we'll just go to alpha beta after this, because I think that's the one people have some issues with. All right, okay, so given the series, a half plus 1 over 2 to the 4 plus 1 over 2 to the 7 plus 1 over 2 to the 10th plus dot dot dot, show that this series is geometric. Now, to show that a series is geometric, it jumped back up to the top there. Right. Okay, so what characteristic differentiates a geometric sequence from an arithmetic sequence? How does an arithmetic sequence progress? By what? Addition or multiplication? Addition. And therefore, how does a geometric sequence progress? By multiplication, right? So to know if it progresses by the same amount, we have to take any term and divide it by the term immediately before it. And to prove it, we actually have to do it at least twice. So that way, we could know that it wasn't just a change in one instance and not the same change in the other instance, right? So the first thing we're going to do is we're going to rewrite the sequence using exponential form, right? So it's 2 to the minus 1, followed then by 2 to the minus 4, then 2 to the minus 7, and 2 to the minus 10, plus dot dot dot. So to prove, like I said, that it is geometric, in that particular case, what we will do is take any term and divide by the term that came immediately before it, right? So laws of indices, when we are dividing and we have the same base, what do we do with the indices? We have to subtract them. So it's minus 4 minus minus 1. Be careful with those negative signs, guys. Minus minus 1 becomes plus 1. What's minus 4 plus 1? Minus 3, right? So that connects these two. What about the next two consecutive terms? We're going to take the 2 to the minus 7 and then do 2 to the divided by the term immediately before it, which is 2 to the minus 4. So we get 2 to the minus 7 minus minus 4, which gives us 2 to the minus 7 plus 4, which gives us 2 to the minus 3, which matches. Does it not? Right, so what we've just done is we've proven that this series is geometric. To prove it's geometric, we have to prove that it advances via multiplying by the same common ratio. To prove that it advances via the same common ratio, you take any term and divide by the term that came before it. And you do that at least twice, right? And we could actually see that that happens here, 2 to the 10 and 2 to the 7, right? You'd have to multiply 2 to the 7 by 2 to the 3, right? Or in this case, divide 1 over 2 to the 7 by 1 over 2 cubed, right? That way the 7 plus the 3 will give us 10. All right, okay. Given the series that, okay, hence find the sum to infinity of this series. All right, so we have a sum to infinity to find. So to find the sum to infinity, all right, the formula we just saw was A, the first term, over 1 minus R, where A is the first term and R is the common ratio, okay? So that would be equal to a half over 1 minus 1 over 2 cubed, right? So if you want, you could kind of simplify this a little bit or restate it in a slightly different way to facilitate working with it. So we have 1 minus, so of course 2 cubed is 8, right? Was 1 minus 1/8. How many eighths in a whole? 8. And 8 minus 1 will give us 7, right? So we have, a half divided by 7/8. And when we're dividing fractions, the protocol, we have to change divide to multiply and then invert the fraction. 8 over 7. Right? 2 will cancel with 8 4 times. So the answer here is 4/7. Hi Amir, how are you? I'm sorry if I took long to respond. Now take a look at the chat there. Alright. Hope you're finding this stuff helpful. Hello to all 4 people watching. Thanks for watching. Alright. Okay. Alright, so anybody here have any questions? No? Alright, those on the live, if you have questions, you can ask, but there's a bit of a delay, so I mightn't see your question until a little after, so you gotta bear with me. Alright, cool. So shall we scroll down? Alright, so we'll have some questions on writing paper there. Okay, so this is the 2012 question. Alright, so we're gonna put that to the top. Alright, so it's just, I'm gonna scratch it out. I just wanna make sure we're not like bothered by those things. A customer repays a loan monthly by increasing the payment by X dollars every month. So right away, if we know this is a sequences question, what type of sequence you think it is? If it's increasing by X dollars, is that an addition or is that a multiplication? As a fixed amount, right? So it seems like, for example, if he was paying it back by, let's say $10, and he increased it by 5, that's 15, then 20, then 30. That seems to be arithmetic, right? If the customer repaid $50 in the 5th month and $70 in the 9th month, calculate the total amount of money repaid, the total amount, and notice total is in capital letters, right? The total amount of money repaid at the end of the 24th month. Okay, so first things first, once again, you have to acknowledge this is an AP, right? It's a term, it's a sequence. Correct, Ali, right? It's an AP. It's increasing by the same amount every month. So let's just reanalyze some stuff. Let's take off some of these things, right? So 50 in the 5th month implies that that's the 5th term. That's the fifth amount he paid back. So T5 is equal to $50. All right, and then $70 in the 9th month. So therefore, the 9th amount that was paid back, the 9th term, was $70. All right. Now, what we could do here is we could utilize that formula, which is the nth term formula. All right. Now, what I want us to find, by the way, we have to find total amount of money. That's the sum of the first 24 terms. And the sum of n terms, if you come across on this side, just very briefly, that formula is n over, that's not an n. Right, n over 2 multiplied by 2a plus n minus 1 by d. Now, we know n is 24, but we neither know what a nor d is. So we have to find a and d. Now, how many unknowns is that? That's 2 unknowns. And what's the basic rule in algebra when you're trying to solve for unknowns? You need at least as many equations as there are unknowns. So if you have 2 unknowns, how many equations we need? We need 2. Okay. So if we once again come back here and we use that formula, a plus n minus 1 by d, right? So if we know this is the 5th term, we have a plus n minus 1. If n is 5, 5 minus 1 is 40. if we know this is the ninth term, 9 minus 1 is 8d. And here we have formed a pair of simultaneous equations. So all we have to do therefore is subtract. And we'll be able to cancel off a, right? 50 minus 70 is minus 20. A minus a will cancel to 0. And 4d minus 8d will give us minus 4d. So all we have to do to solve for d now is divide by minus 4 on both sides of the equation to give us 5. So we know what d is, so now we could go back and find a. Agreed? So let's take 50, right? So a plus 4 by d was equal to 50. 4 by 5 will give us 20. And then of course to find a, we simply have to subtract 20 from both sides of the equation to give us $30. So we found a, we found d, and we know what n is. So now if you want to find the sum of the first 24 terms, all we have to do is plug it in the formula. So we have n over 2 multiplied by 2 by a plus n minus 1 by, oops, ran out of space there. Let me just shift it down a little bit, right? Erase number. 24 over 2 multiplied by 2a plus n minus 1. N is 24 minus 1 by d. D was 5, yeah? Alright, lovely. Right, so 24 over 2 will give us 12. 2 by 30 is 60. 24 minus 1 is 23, and 23 by 5 is 115. So essentially we have 12 multiplied by 175. So that's 1200 plus 840, which is 2040, 2040, and 60 is 2100. Alright. $2,100. So at the end of 2 years, they've paid back $2,100. Alright, and 5 marks. Yeah, okay, I can see the 5 marks. You're gonna basically, let me see if I could just, right. So you probably get a little tick each here for getting those formulae. You get a next tick for subtracting, a next tick for solving for D, a tick for solving for A, substitution, working answer. So we have how many ticks there? 1, 2, 3, 4, 5, 6, 7, 8. Maybe 2 extra ticks somewhere. So each tick is about a half mark usually. Right? So I think there was enough scope here to get that full 5 marks, right? So even if you can't figure out the whole question, figure out pieces, right? You do know how to do things, get the marks where you know how to get them. If you can't do something, move on, right? Leave it. All right, we're going again. So that was 2012. Let's take a look at 2013. All right, 2013 actually was a tricky one, I'm not gonna lie. The first time I took a look at this, I didn't know what to do. I was like, what is this? But it actually was easier than it appeared, especially since they gave you a note. What does the note say? The series can be written as the sum of 2 geometric series. So if we look at the series itself, we have 2 terms that kind of follow on from each other, the 1 over 4 and the 1 over 4 cubed. And then we have the 2 over 4 cubed and the 2 over 4 to the 4. So those two seem to go together as well. Because there's no way to go from, even if you were to cancel that down. So let's say you had a quarter. Now 4 squared is 16, right? And if you cancel, if you say, okay, 2 will cancel with 16 8 times, right? But then the 4 cubed was 64. And then 4 to the power 4, that was 196. Sorry, 4 by 4 is 16, 16 is 256. And then 2 will cancel with that, making it 1 over 128. So, did I do that correctly? Yeah, I think I did. All right. So there was no pattern. These terms weren't in series, right? But if we split it up like this, right? 1 quarter plus a quarter cube. Sorry, plus dot dot dot. Plus 2 over 4 squared and 2 over 4 to the 4 plus dot dot dot, boom. If we did that, does it look a bit more workable now? Right? Because we now have, like I said, two geometric series. For each now, we can find the sum to infinity because it's easy to spot the first term for each and almost obvious to find the common ratio. As a matter of fact, I believe for each of them the common ratio is the same. Right? To go from 1 over 4 to 1 over 4 cubed as multiplied by 1 over 4 squared. And the same thing here. Right? 2 over 4 squared to go to 2 over 4 to the fourth as multiplied by the same 1 over 4 squared. Alright? So that was the big trick in this question. Alright, so what I would do is I would state my formula for sum to infinity. Sum to infinity is a over 1 minus r. Alright, so for the first series, a is equal to a quarter, r is equal to 1 over 4 squared. From here now, sum to infinity would be what? Quarter over 1 minus 4 squared, which we can just put as 1 over 16. Alright, we can rewrite that using division. 1 minus 1/16 will give us 15/16. And what's the protocol for the dividing fractions? Change divisor, multiply, and then invert. Alright, 4 into 16 goes 4 times. So we have 4/15 there. And then we can do the second series. Alright, so a was equal to 2 over 4 squared. And r was the same 1 over 4 squared. Alright, sum to infinity is a, 2 over 4 squared, over 1 minus r. Which will be, alright, so we have 2 over 4 squared divided by the same 15/16. Now 4 squared is 16, not so? Inverting and multiplying will give us 16 over 15, which means the 16th will cancel, leaving us with 2/15. Now don't forget, it was the sum of those two sequences, or those two series rather. Erase. So therefore, the sum to infinity of that series there, I'm not even sure, sorry, if that can be accurately called a series. Because the series is the sum to, anyhow, right, technically we could. 15. So we sum together those two, sorry, why do I have 2 over 12? Erase, right? That gives us 6 over 15, which will cancel to 2/5. Okay. How are you feeling with that? Okay-ish? Yeah? So that was in 2013, 14, 15, 16, 17. Right, I know we have a couple more. So let's get on that one time. Turn one time to 2014. Scroll down a little bit. Alright, so for part C, the series is given by 0.2, 0.02, 0.002, 0.0002. Show that this series is geometric. 3 marks, boy? Wow, okay. And finally, they seem to like something infinity in the first few years, didn't they? Alright, okay. How do we prove a series is geometric? Define R. You divide any term by the term immediately before it. Alright? So R would be equal to, let's say, so this is T1. Don't want to erase. Fine. So T1, T2, T3, T4. Okay, so we take any term and divide by the term immediately before it, which will give us 1/10. And then we could double check that by taking 0.002 and dividing by 0.02. Right, because if we had to move the decimal point, it would be 3 spaces in the numerator and 3 spaces in the denominator. So you get 2 over 20, which gives us 1/10. Right? And if you want to be extra, you could show it works for the final one too, 0.0002 over 0.002, the same 1/10. Alright, or if you want, you could have just stated that 0.2 by a tenth is equal to 0.02 by a tenth. Sorry, 0.2 by a tenth is 0.02. 0.02 by a tenth is 0.002, and so on. Alright, and the sum to infinity formula, a over 1 minus r. A is what? That's 0.2. 1 minus r is 1 minus 0.1. So that gives us 0.2 over 0.9, which is just going to give us 2/9. And leave your answer as an exact fraction. So I know some of you like to jump and round off to 0.22 on these things, and even 0.222, 3 decimal places or 3 significant figures, all kind of fanciness. That's all well and good, right? But always give the question what it wants, right? I'm not entirely sure why the first one was 3 marks, right? Some infinity could very well be 2 marks. It's as in this particular case, nothing too elaborate to have to do. Alright, so it was not a big deal. So that's 2014. Moving on to 2015. An employee of a company is offered a starting salary of $36,000, which increases by $2,400 per annum. Sorry. Determine the annual salary that the employee should receive in the 9th year. Okay, so it starts off with 36,000 as your A term. It increases by 2,400 per annum. That's what? That's D. So the annual salary. So would that be the sum of n terms or just the nth term? I think it's just the nth term. Yeah. So nth term of an AP. Oops, sorry, that's not looking very neat. It's a little better, right? That's A plus n minus 1 by D. Start off with 36,000 in year 1. In the 9th year, right? So that 9th is as 9 minus 1 by D, which is 2,400. 9 minus 1 is 8, so we have 36,000 plus 8 by 24. Whoops. 100. Eight by 24, that's 19,002, which gives us 55,200. Yeah, all right. Yeah, so they weren't overly challenging. The start 2013 one was a little tricky, to be honest. Too many nature roots, boy. Sketch that function. So we have, this was, I think was one of the only times they brought sigma notation in a long paper. I think there was a couple instances of it in a short paper. Alright, so what we're going to do, let's just zoom in a little bit to have some more room. Alright, so this is evaluate 3 to the minus n from 1 to 25. So that's what this means, right? Evaluate the sum of this particular sequence, or series, I guess, a series is the sum of a sequence, right? From the first term to the 25th term. Right, so of course, so this term on the bottom below the sigma sign is the starting term, and this is the ending term. Alright, so let's just figure out, and by the way, this is raised to a power, right? Which of those sequences, when we looked at them, APs or GPs, was exponential in nature? APs or GPs? Which one? GPs, right? Because that was when you multiplied. What was the sum, what was the nth term of a GP called again? Oh, the formula, sorry. Right, that was a by r to the power n minus 1. So that kind of looks like this. So most likely this is going to be a GP, and we're simply going to have to apply the formula for the sum of the n terms in a GP. But of course we have to figure out a and r. So the first term would simply be where n is 1. So that's 3 to the minus 1, so we have minus 3. Right? The second term would simply be 3 to the minus 2, which is 1 over 3 squared. And so it will continue. So basically all you're doing, whatever term, right, whatever term it is, it's 1 over 3 raised to that power. Right, as the nth term in this particular thing. So here we could see clearly that r is also equal to 1/3. Because if you went from the first term to the second term and you had 1/3 to 1 over 3 squared, and the third term would simply have been 1 over 3 cubed, right? We could surmise that r is equal to 1/3. If you want to show the working, that's all well and good, right? You could say, okay, T3 is 1 over 3 cubed. And you could say, therefore, r is equal to 1/3. So we want the sum of the first 25 terms, right? So the sum of the first n terms of a GP is what? A multiplied by 1 minus r to the n all over 1 minus r. We know the first term is 1/3. That's 1 minus a third to the power. What power is that? 25? Wow. Alright. All over 1 minus a third. So that's something you can simply plug into a calculator. Now this was just 3 marks. So it implies it wasn't meant to be overly difficult, right? It was meant to be relatively simple. But of course you had to know what you were doing. Everything is simple if you know what you're doing, right? But if you don't know, of course, it's not so simple anymore. Alright, so what ends up happening is actually the 1 minus 1/3 gives us 2/3, right? And that 2/3 actually, so let me show you. I'm getting like 1/3 multiplied by 1 minus 1 over 3 to the 25. And that's divided by 2/3. So of course this is going to flip. And the 3's will cancel. So what it will boil down to is equal to 2 multiplied by 1 minus a third to the power 25. Now it says evaluate, so I'm assuming that we could actually get a value in a calculator. Anybody? Anything? It'll be very close to 2, like 1.99 something. To the 3 to the power 25, I mean, 3 to the power 25 is relatively high. So 1 over that would be relatively small. If you subtract something relatively small from 1, you're going to get back almost like 0.99 something. And when you multiply that by 2, you're going to get approximately 2 when you take it. Alright, so yeah, so someone just multiply that out, let me know what you get, and then we'll go to part C. And it was also the first day they brought 2 questions on APGPs, one with GP and one with AP. 1.18 by 10 to the power minus 12. Minus 12? Let me see. I'm not allowed out in here, that's what I see. Oh, that's what 1/3 to the power 25 is. Oh, alright, multiply that now by 2. 2.36. Oh, I forgot the minus from 1 first. Oh, so it's 1 minus 1 over 3, and that's raised to the power 25. The calculator says 1 multiplied by 2 equals 2, right? So like I said, it's going to be so 1/3 to the power 25 is so ridiculously small. When you minus 1 from it, you might as well get back 1. You get like 0.9. Because if it says 1.18 by 10 to the minus 12, so that means you have 11 zeros in front of that 1. So that means you get 0.99 and it's 11 nines going down the line, right? So that's approximately equal to 2 anyway you take it. Alright, so yeah, so you didn't actually need a calculator, but I know some of you all like it, right? Sharita, 2, that's correct. Thank you for your input. Okay, I'll just zoom out a little bit in case anybody wants to just absorb that one a little more. And while you do that, we're going to read down here. This one was a nice one. When I say nice, I mean it was a little tricky, right? It made you think. You had to be aware. It wasn't just plug and play. And that is the stuff that where the real money is in terms of being able to think. So when I'm doing POB revision, the day before the exam, probably 10 to 12 and 1 to 3. Right? If you'll find it have a lag between when you ask me the question and when I answer, I'm real sorry about that, but that's just how the life does work. Yeah? All right, a man invested X dollars in a company in Jan 2010. All right, so Jan 2010 is when he invested, on which he earns quarterly dividends. Now, when they say quarterly dividends, if you think of your year, right? How many months in a year? 12. Jan, February, March, April, May, June, July, August, September, October, November, December. And you have Jason somewhere here, right? Cool. So what's a quarter of 12? That's 3, right? So if we divide this year into quarters, right? So what it means is if you invest in January, the first of the quarterly dividends, on which year? At the end of the second, third, and fourth quarter in 2011, he earned those things. All right. Calculate total dividends on his investment. So total dividends implies they want the sum of all the dividends that you receive, right? So if we assume that he starts collecting dividends in the same year as his investment, right? He's going to collect one here, second. So hold on. This is the first term will be here, second term, third term, and then the fourth term. We okay with that? No, that's in 2010. In 2011, it says at the end of the second, third, and fourth quarter. So this is the first quarter here, right? This quarter 1, this quarter 2, quarter 3, and quarter 4. Now, if at the end of 2010, right, December 2010 would have been his fourth set of dividends, agreed? So the next set of dividends would take place at the end of March in 2011. But that would be the what? What number dividend you would receive? Which term is that? That's the fifth term, right? So that's the fifth term, then there's the sixth term. So this is 2010 here. Yeah. Erase now, behave, right? This 2010, this 2011. Right, this would be T7. And at the end in December here we have 8, right? So they said at the end of the second, third, and fourth quarters, which is here, he received 100, 115, and 130. So, in respect of that, which terms would those be? That would be term 6, term 7, and term 8. Alright? So, term 6, they told us is 100. Term 7 is 115, sorry. Right? And term 8 is equal to 130. So, therefore, what's the common difference? We have to subtract, right? Any term from the term before it. Any term minus the term before it, sorry. So that's $15. Right? And we want the sum, right? The total dividends on his investment by the end of 2016. So check this, right? From 2010 to 2016, how many years is that? Now you might rush and say, well, that's 6 years. But consider it this way, right? If you're going from January to January, I would very much agree with you and say that would be 6 years. But if you're going from the start of January to the end of December, that adds an extra year. So he started in January 2010 and they want the total dividends by the end of 2016. It means you have to count 2010, 2011, 2012, 2013, 14, 15, and 16. So that's 7 years. But how many are you getting paid yearly or quarterly here? Quarterly. So how many payments is that per year? 4. So if it's 7 years by 4 payments a year, how many dividends would he have received in total then? 7 by 4 is 28. Right? So they actually want the sum of the first 28 terms. Right? So that would be n over 2, 28 over 2, multiplied by 2 by a. Oops, we do have a, right? Plus n minus 1 by d. Now, how do we find a, boy? Well, we could work backwards from any one of these terms, right? What's the formula for the nth term? Right? That's a plus n minus 1 by d. So let's take 100, right? So 100 is equal to a, and that was the sixth term, right? Plus 5 by 15. So 100 is equal to a. 5 by 15 is 75. So therefore, to find a, we'd simply have to subtract 75 from both sides of the equation. Therefore, a is equal to 25. Boom, 25. Right, so 28 over 2 will give us 14. 2 by 25 is 50. 28 minus 1 is 27. Well, let's do 30 by 15. 30 by 15 is 450. Minus 2 groups of 15, which will be 30. So 450 minus 30 is 420. Please feel free to let me know. 15 by 27, that's 270 plus 130. Yeah, no, that's not it. No, it was 45. It was 450 minus 405. Right, sorry. It was. I went back to 28 instead of going to 27. Yeah, I should have known that because it's 27 by 15. Alright, so that's 14 multiplied by 455. Let me see. 400 by 14. That's 5600. Plus 700, 63. 6370. Anybody? Yeah? Alright. Nice. And that was 5 marks. Right? So yeah, I think that was worth the 5 marks. You probably got a mark for deriving D. A mark or 2. You probably got 2 across here. And you probably got 2 for this as well. Alright, so yes, so that was a nice question. Like I said, nice because it made you think a little extra. Alright, so that was 10 and 16. Aha! We got some alpha beta stuff. We'll come back to that just now. Let's knock out all of these APGP questions and then do whatever else we have to do on this. We'll probably start with the alpha beta. Alright, an accountant is offered a 5-year contract with an annual increase. Annual increase. The accountant earned a salary of this and this in the 3rd and 5th years respectively. If it follows a geometric series, calculate, oops, all this extra stuff, right, geometric. So what they mean here is that it's scaling up by a fixed, well, a percentage every year. Like it's getting a 10% increase or a 12% increase. Now, something that's very important about that. 12%, let's say it was 12%, right? 12% is equal to 0.12. But if you were to multiply something by 0.12, you'd only get 12% of it, not so? That's the increase. To be able to go from whatever the start term is to add in, exactly, it'll be 100, yeah, that's great. It'll be 112%, right? Yeah, Sharita, that's okay. That's all right. We make mistakes all the time, right? Learn from them. Right, so like I was saying, if you want to go from the first term to the second term, you have to add 12%, yes. Right, but you're not multiplying by 12% to go to that term. Right, you're adding 12% onto it. Now, what that means is that the first term is 100% of itself. And when you add 12% to it, it means the second term will be what? 112%. And that means that your common ratio would be 1.12, or your multiplier would be 1.12. Right, so if it was 20%, 20% is 0.2, right? So your multiplier would be, if it's increasing by 20%, it'd be 1.2. If it was a 15% increase, your multiplier would be 1.15 and so forth and so on. Alright? Okay, so they want the amount paid in the first year. So in other words, we are required to find A, not so? So we are required to find A. Alright, so hold on. What else? The total salary earned at the end of the contract. Okay. That's done. Right. So 3rd and 5th year. So the 3rd term was 53. So, well, I have 5 underscore 3 boys. 53, 982.8. And the 5th term. Good. Car sneezing going on the road. Yes, boys. It's bad. Car sound like it have severe nasal distress. Alright, so to find A, what's the formula for the nth term of a GP, sorry? Right, that's A multiplied by R to the power what? N minus 1, right? N minus 1. So we could put any of those. So for example, we could say, alright, 53, 982, Shaliza. Alright, that's on Tuesday, Shaliza. Right, 53,982. So you're all in the exam, doing some POB stuff, right? 53,982 multiplied by r to the n minus 1. Now r, we don't have r. Right, now given that is the third term, that would just be 3 minus 1 here, right? Oh, that's right? Oh, no, sorry, my bad. Thanks. Right, that's a by r to the 3 minus 1. Now we have two unknowns. Right, now you can create a second equation. Right, 598.89 is equal to a by r to the 5 minus 1. So here we have two unknowns, two equations. So if you all had to do simultaneous here, what would that look like? Right, and what we could do in each case is we can make a the subject of the formula, because that's what they're asking for, not so? So we can simply have 53,982.8 all over r squared, and down here in the second equation we get a is equal to 598.89 over r to the fourth, yeah? So what we could do is we could put those two things equal to each other. When you solve, you end up solving for r. Alright? So we're gonna let 53,982.8 over r squared equal to 598.89 all over r to the power 4. Right, we could actually multiply by, sorry, that falls a big. We could multiply by r squared on both sides to cancel off the r squared on the left hand side. So 53,982.8 will be clear of a denominator, right? 0.89. This is going to be over r squared here. And now all we'd have to do is just kind of, as I say, cross multiply, right? So essentially what would happen, you would end up with r squared is equal to 598.89 all over 53,982.8. And to find r, we have to find the square root of that item above, which would be approximately, anybody want to help me on that one there? Cornelia have from 2005 to 2018. Well, Cornelia, best you share with everybody else, including me. I'm just kidding. Here's where I wish I bought a nice calculator. Oh, things flowing alright on the live there. You'll see on the screen. So everybody writing. Like I said, my penmanship sank. I have a penman dinghy. A penman life preserver. Like me a whole penman and me a pen boy. I'm sure. .06. Alright. 1.06. What was beyond that, by the way? No, when I say one, well, it wasn't just, it was 1.06 exactly? 595? Do I want, okay, well, depending on whether you round up to 1.06 or use 5.95, what was after that second 5, by the way? 0, okay, so 5.95% could be used, right? So you could use 1.06, right, which means a 6% increase, or you could round it back and do 5.95, right? Now, we're not done, we just found R. We have to now go and find A. So we could use either one of these, right? So here I want you guys to do. I want one of you all to do the top one to do the bottom one, and one of you to just do whichever one you want. So Zelia do the top one, Sky do the bottom one, the R to the fourth, and you do whichever one you want. Alright, so A would be equal to, you're using 6%? Just flat 6, or 1.06? Yeah, okay, that's fine. So 53, 982.8 all over 1.06 squared, right? 1.06 squared, which would be approximately. So Cornelia, was it a book you bought in a bookstore, or was it something you bought not in a bookstore? Any takers? Anybody anything? 48,000 044 so 0.5 then approximately. Anybody else will confirm that? Anybody got something different?
I got 47,999.997.
4799. So it looks like it's about 48 then, because what would have happened is because we rounded off, and because you use the r squared, you use the r to the fourth, right? Because of that, you would have had a difference depending on what. Because I remember when I posted the solutions up, people were messaging me saying, "Well, I didn't get that. I got 47 or 40, whatever, right?" So the thing is, what you probably could do is, if you know how to do it, leave the exact value of whatever you get here in your calculator, and use that to find the quote-unquote correct value of A. All right. So, Karen, what do you got? 48,044. All right. Can I borrow yours for a second? I just want to see what I would get if I had it. Cool. That's a fancy one here, boy. So I'm gonna take it out. 0.89 divided by 53,982.8. Right. And then what we want to do is we're going to raise that to the power 0.5. Alright, 1.0. Okay, cool. And then what we want to do with that now is we want to square it again, equals, and we want to do that, equals, and then multiply that by 53,982.8, 92.8 equals. Alright. So what I actually would have gotten would have been 48,089.04. So I think once you're in the vicinity of 48,000 or thereabouts, I think you're fine. I think they would have catered for those who would have rounded off to 6%. All right. And honestly, that might have been the easiest thing to do, but that doesn't mean it was the right thing to do, right? But like I said, I think they would have catered to that. All right. So 48,089. Or if you want me to just use a flat 48,000. But whichever figure you use, I'm fine with it, because, like I said, our range of answers here, in my opinion, would have been fine. Right? Because they could not, force people to use one or the other. Right? But like I said, a good protocol to follow is, if you do have answers that require a lot of rounding off, you can put a rounded figure in your statements, right? Or put like ... to signify that, look, there's more to this, right? So you could put ... to show that you're not using exactly 1.06, you're using 1.06 and change, or whatever it was, right? And therefore, you would have gotten that answer. All right. Moving from there, the total salary earned at the end of the contract. So total implies summing. So we're gonna have to add up, right? All right. Okay. I know what your time is. It's 1/2 past. So you have 20 minutes again, right? All right. So I just want to make sure I finish all the APGP stuff, so that way. All right. Saturday, Sunday, Monday. All right. We'll confirm what we'll do Monday by Monday, right? I'll message tomorrow and that kind of stuff, right? So like I said, my Form 6s, they're kind of asking for more sessions. So I might give them the 10 to 12 on Monday, if anything. All right. Okay, an accountant is offered a 5-year contract with an annual increase. So 5-year contract. So we have to basically do the sum of the 5 terms in this GP. All right. So sum of n terms of a GP is equal to A multiplied by r to the n minus 1 all over r minus 1. All right. So we could use, all right, let's use the 48 and 44. All right. we could use, because that's what we got with the 1.06, right? All right. So 48 over 44.50, right? Multiplied by, so I'm going to use 1.06 to the power n, which is 5 minus 1, all over 1.06 minus 1. Right? If you wanted to be more exact, of course, you could use it dot dot dot. Sharita, when is your next live? Sharita, it will be Monday. I have to confirm whether it'll be 1 o'clock or 4 o'clock. Right? And it probably will be a double session with a half an hour break in between. So it'll either go from 1 to 3, and then we'll take a break until about half 3, and then we'll go like half 3 to 6, or we might do a 4 to 6 and a half 6 to half 8. Right? Yeah, tomorrow, I'm taking the day off tomorrow because I need a little rest. I know all they have work to do, sorry I can't help it tomorrow, but once again, I have full past paper solutions on Facebook. Look for 8 different approach tuition limited, the same name as highlighted in the when I put a comment. Alright. What did I do? Oh, apparently I have a shortcut key. If you press F, you go full screen. Did not know that, now I do. Alright. So, anybody else knew that? No? Alright, cool. Alright, anybody worked it out calculator wise?
I got 15,343.29.
15,000 or 153? That makes sense? Yeah, check it again. Be careful with the how you input stuff into your calculator, because when you have multiple layers to do work in, yeah, it might be smart to do the numerator and then press equals and then put that to divide by your denominator. And if you can work out a piece of it, like for example, 1.06 minus 1 is just 0.06, right? So you could probably just work out 400? Oh, sorry. 270? Point. Oh, cool. You guys got anything around that? No? Alright, let me double check. Just in case, right? Okay, so like I said, what I would do, is it on? On, right, cool. What I would do, alright, so I'll do the 48 over 44.5. Multiply, open brackets, 1.06 to the power 5, and then minus 1 from that. Right, so I have 16 to, oh no, I know what happened here. When we did 1.06 to the power of 5 and then we put minus 1, it pulled the power of 5 minus 1. I suspect that's what happened, because if you take 1.06 to the power of 5 and then a minus 1, no, that is possible, because now if they divide by 0.06, right, I have 270, 833.00, so it wasn't too far off. But let me double check. Skylar, you get anything close to those things now?
Same thing I thought before.
15,000?
2 times.
Wow! 15,000?
No, around 16,000.
16.
No, 15,339.07.
But the sum?
When I work this out.
Alright, here's what to do. Work out the numerator. Start with 1.06. Start with 1.06 to the power 5, then press equals. Tell me I get 1.338 and change. Now minus 1 from that. So you get 0.338, right? Now we're multiplying by 48044.5. Tell me I get 16,249.87. And now divide that by 0.06. Because 1.06 minus 1 is already 0.06, right? So you just divide that by 0.06. 270, right? So if you're working out stuff in your calculator and you surmise, look, this probably cannot be correct, use BOMDAS. As in, what's the first thing to do with BOMDAS? Brackets, right? Go in the brackets, work out your brackets first, and then go out from there. And after each time you do a calculation, press equals. All right? Because yes, calculator work could take a lot of practice. All right? That is definitely something that could require plenty of practice, because I mean, it is not always intuitive. Especially people using a phone card. Now, you cannot use your phone in the exam. Do not, anybody in live, don't carry a phone in the exam. We want no more, what's the word? Why I can't think of words? I'm not at math right now. I want to say scandals. Scandal might be the wrong word, but let me say that. We want no more incidences, whatever. We want nothing like what happened in Masters and Tabna again. Alright? Don't do that. Okay. Shall we proceed? So that was 27. Okay, so one more to go, and then we had to hit some other topics. Alright, let me just check the part C to this question. Was there? Oh, part C was alpha beta. Okay, cool. In a geometric progression, the third term is 25. Let's jot it down. So we have a GP, a general practitioner. Do I have one of these? Hold on, 1 second. No, okay. So GP, right? The third term is 25. The sum of the first and second terms is 150. First term plus second term is 150. Alright. So can you email me past papers? You can't be asking about them on a live CXC might be watching. So my official answer is no. Sorry. Alright. So determine the sum of the first 4 terms given that r is greater than 0. So r greater than 0 means r is positive, right? It should really have said r greater than 1 because, I mean, what's the point of having r as 1? Anyhow. No, but then again, r could be a fraction. That's not impossible. Okay, cool. So we have to find the sum of the first 4 terms. So we are required to find the sum of the first 4 terms. Right? Now if you want to do it lengthways, as term 1 plus term 2 plus term 3 plus term 4. And we have term 1 and term 2 already, right? If you add those two together, and we already have term 3. So technically we're 3/4 of the way there. All we have to do is add 25 to 150 and we have what we need, right? And think about it. Check this, right? Let's imagine the first term is 100, the second term is 50, this is 25, right? Does that look like it might be in a geometric progression? First term is 100, what's a half by 100? 50. What's a half by 50? 25. And a half by 25 is 12.5. But of course, it cannot be as simple as that. I don't know if you'll get your full, how many marks? 4 marks just for doing that. But I mean, if you could see it, you could at least know where you're going, right? So now we have to prove that that is actually what it is. Okay, so how do we do that? What's the formula for the nth term of a GP? All right? The nth term is a by r to the power n minus 1. Okay, so T1 is just a, not so? Because if n is 1, 1 minus 1 is what? 0. And r to the power is 0. What's anything raised to the power 0? 1. And a by 1 is just a, not so? And then here, T2 would simply be a by r. And that's equal to 150. And then they're telling us that the third term, AR squared is equal to 25. So, technically we have 2 unknowns, a and r. Not technically, we have 2 unknowns, a and r, and we have 2 equations. So we could solve for both unknowns. But I mean, really and truly, realistically speaking, all we really need is the 4th term. So if there was an a just to find, if there was a way just to find r, all we have to really do is multiply r by 25. We get the 4th term and then we go from there. Alright, so can we solve for r? Actually we could. Could we? Okay, check this. From this piece here, right? If you factorize out a, you get a by 1 plus r, and that's equal to 150, not so? And if you want to make a the subject, you would divide on both sides by 1 plus r, not so? Now here, to make a the subject, we'd simply have to take 25 and divide by r squared. And since this is a, and this is a, guess what we could do? Put them equal to each other. Alright, so what we would do is we would let 25 over r squared equal to 150 over 1 plus r. You cross multiply, you get 25 plus 25r equal to 150. We could divide everything by 25 to scale it down, so we have 1 plus r, sorry, I forgot to put r squared, equal to 6r squared. And from here now we could bring everything on one side of the equation. 6r squared minus r minus 1. What's 6 by minus 1? That's minus 6, right? You could factorize that? Yeah, I think we could do that, right? Well, what are the factors of 6? 3 and 2, 1 and 6. If we have minus 3 and positive 2, we could do that. Minus 3r plus 2r minus 1. We could pull out 3r as the common factor to the front. Sorry, 3r, 2r minus 1. And then of course, there is no common factor here other than 1. So you pull 1 as the common factor. You get 2r minus 1. So 0 is equal to 2r minus 1 by Shaliza. But you put like 20 r's after it now, so that's, you know. Was I supposed to roll the r's? I don't know. So these r's, sorry, my official answer is I cannot send you past papers. Right? You can go onto CXE's website, cxe-store.com. Wink, wink at CXE. Right? So from here, we could say that either 2r minus 1 is equal to 0, in which case 2r is equal to 1 and r is equal to a half. Now from here, r will be equal to minus a third. We can neglect that because the question specifically said that r is greater than 0, which implies that it is positive. So now that we know that r is a half, all we have to do, alright, so instead of having to go back and try and solve for a, all we have to do is say, okay, look, if we take t3 and multiply by r, that's ar squared by r, we get ar cubed, which is fourth term. Right? So if we take 25 and multiply by a half, we get 12.5. The sum of the first four terms, right, will be equal to, once again, term 1 plus term 2 plus term 3 plus term 4. So we didn't have to work out what term 1 and term 2 were. We knew their sum already. That was given to us. So that was 150 plus, sorry, not 50, plus 25 plus 12.5. Right? 50 and 25 is 75, 75 and 12.5. So that's 187.5. All right. So I think that one was worth 4 marks, right, for sure. I would even go as far as that might be a 5-mark question, in my opinion, right? At least, you know, for you all. Sorry. Okay. So we're gonna rounds back and try some of those alpha beta questions, but before that, Monday. So Monday most likely we have in 2 sessions. In those 2 sessions, what do you all want to cover? Somebody said logs. 2 of you all said logs, right? You said equation of a circle. Anybody want to do a few differentiation integration, or what else you all want to do? All right, you have vectors. Vectors is attached to coordinate geometry, which is the equation of a circle. We did trigs. We did plenty trigs. That's question 4. Question 5 is differentiation. 6 is integration. 7 is probability and statistics. 8 is kinematics. All right. Of course, we could touch on some of that if anybody wants. Or you could just go back and check the Skylar, like, not mean kinematics. All right. We're doing question 2s now. Like I said, we might be able to get through some of those alpha beta things. Maybe a couple inequalities here and there. Question 1 is the one that has the logs, functions, remainder factor theorem. All right. So maybe we could touch there, especially with the logs and the log graphs. Right? Because I was doing that recently with some of my students in Form 4. Alright. Yeah, any input? So log the equation of a circle. What else? This guy is quadratic, right? Sorry, somebody asked for that. That's in question 1. That's indices. Alright, cool. So Monday we'll tackle some question 1, some question 3. We did 4 already. This is 2. And maybe flinging some differentiation integration in the second session or something. And we could do 1 hour differentiation, 1 hour integration. And I'm assuming you're okay with the props and stats. Because if not, well, I could fling in a third session. If what you want. But you had to talk early so I could tell my one student not to come. Alright. Okay, 2:45. What we're gonna let's go back up one piece at a time. Sorry, hold on. That was a little too fast. What was below here? Oh, look, we are alpha beta, boy. Alright, so just for integration. Alright, we'll try and see if we can fit in some calculus for the people then. Alright, let's just do a bit of recap with alpha and beta, right? So alpha and beta. Let's see what it pulls up as what it recognized. Alpha and beta. Okay, so if we have a generic quadratic, ax squared plus bx plus c, and that's equal to 0. If we divide it by a on both sides, we have x squared plus b over a by x plus c over a. Alright, oh, equal to 0, sorry. So what we're saying is that if sorry, why am I zoomed still? Let's zoom out a little bit. Zoom out, right? So this has roots of alpha and beta. Right, cool. And we know that alpha plus beta is the sum of the roots of a quadratic, and alpha by beta is the product. And we know that there's a generic expression, another generic expression, which is this. Alright, so if we pair them up, x squared minus alpha plus beta by x plus alpha by beta, we could simply, by sight, we could say, okay, well, alpha plus beta is equal to minus b over a, and alpha by beta is equal to c over a. But of course, things don't stay that simple, do they? Right? They love to bring a few things for you. They love to bring 1 over alpha plus 1 over beta. So what we'll do is we'll take a look at that one time. So when you're adding fractions, what's the protocol? You need to have a common what? Denominator. So the LCM here between alpha and beta is just what? Alpha beta. Alpha into alpha beta goes alpha times, leaving us with beta, not so? Sorry, alpha into alpha beta goes beta times, and beta by 1 will give us beta in the numerator, beta in the numerator. And then beta into that goes alpha times, alpha by 1 will give us back alpha. So this here, and of course beta plus alpha is the same as alpha plus beta, not so? So this is equal to the sum of the roots over the product, which is just this divided by that, which actually would give us this minus b over c, if you're curious, right? They also like to give you all alpha squared plus beta squared. Now, from here, a lot of people thought, well, this is just alpha plus beta all squared, but we know that's not the case. Why? Because if you expand alpha plus beta, it's going to be a plus 2ab on the inside there. Right? Sorry, I don't know how that scrolled down. Right? If we expand that, there's going to be an alpha squared plus 2 alpha beta plus beta squared. So to make it just alpha beta, you have to take out 2 alpha beta, which means you have to subtract it. Alright, so this is your alpha squared plus beta squared shorthand there. Alright, so basically what you have to do is whatever they give you to find in terms of alpha and beta, you have to see how it can simplify into one of or both of those things, or some combination of them, or some manipulation of them. All right, so those are the basics. So I think there were only 2 or 3 alpha beta questions, so we should be able to finish that. It's 10 to you want to see the outside, or they'll call it when they're here. I've seen a red pickup truck. That's for you. Yeah. That's for you? Alright. Okay. Alright, so Monday, you're available Monday, right? Yeah, okay. So I'll confirm what time in the WhatsApp. I have a broadcast for you all, right? So I'll just message and let you all know, right? Alright. Alright guys, so just give me one minute. I just need to get some water real quick. Sorry. I can. What? That's sun. That's sun, boy. We are welding goggles that you go outside, I guess. And I get archive. Seeing spots. And alright, so okay, so we're back here. So this is actually 20. That's the spec, so no alphabet in the specimen paper 2012. Alright. Here we go. First question. So let me zoom in a little bit. So the first question was this one here, right? And you have to find the value of alpha squared plus beta squared. Right, so alpha squared plus beta squared, we know from the previous page, is the square of alpha plus beta minus 2 alpha beta. Right, so let's come up here, shall we? So first thing we should do is actually identify A, B, and C. Alright, so alpha plus beta is equal to, well, minus B over A, sorry. And alpha by beta is equal to C over A. Alright, so value of A has the coefficient of x squared, which is 1. Value of B is the coefficient of x, which is minus 4. Value of C is the constant, which is positive 6. So minus B over A is minus 4 over 1, which is just minus 4. Alpha by beta is C over A, which in this case is 6 over 1, which gives us 6. Alright, so therefore, alpha squared plus beta squared will be equal to alpha plus beta was minus 4. Sorry, let me write it out long ways, right? So alpha plus beta squared minus 2 by alpha beta. So alpha plus beta was minus 4. That's minus 4 squared multiplied by 2 by alpha by beta, which is 6. Alright, minus 4 squared is 16. 2 by 6 is 12. And 16 minus 12 is 4. Sorry, 4. Okay. Alright. Sorry, 1 second. Hi, good afternoon. I in our class. I'm going to call back in 10 minutes now. Yeah. Alright. Alright, cool man, yeah. Sorry guys, on the live. Alright, let me just do a little quick transition back to that. So you'll just see here for a couple seconds. I'm just gonna go back here. Alright. It's not a thing in, it's nothing in. Why nothing in? Oh right, cool. Transition back to that. Right, sorry. Okay, we're back in business. Okay, so that was 2012. Hold on, any alpha beta here? Nah. That's 2013, not seen any alpha beta there. 2014, no alpha beta again, but you're noticing completing the square coming almost every year, right? Well, at least in the earlies. And there was an inequality that year too. All right, we have one here. So let me I'll zoom in a little bit. That's a lot. I must have no room to do any working. All right, go down, go down. Too far, come back up. All right, so this is the quadratic, and this is what we have to go to. All right, so we saw from earlier 1 over alpha plus 1 over beta. This ended up being alpha plus beta over alpha by beta. All right, so we go in there. All right, so we'll start off by writing that out. So that's 3x squared minus 6x plus 4 equals 0. Laptop, but okay. All right, so a is equal to 3, b is equal to minus 6, c is equal to minus 4. All right. 1 over alpha plus 1 over beta is equal to alpha plus beta over alpha by beta. Alright, so we know that alpha plus beta is b over a. Did I do minus b just now in the previous question?
Yeah.
I did? Okay. For some reason, I just feel like I didn't. Alright, so that's minus 6. Right, because it was minus 4, and minus was positive 4. Yeah, okay, cool. So minus 6 over 3. So minus 6 is positive 6. 6 over 3 is 2. Yeah? Alright. Alpha by beta is equal to c over a. So that's minus 4 over 3. Alright, so scratch that out because next thing I put 34. Cool. Alpha plus beta. Right, so that's 2 over minus 4/3. So you can rewrite that if you wish, like this, which would make it easier to facilitate working with fractions, which would therefore just give us minus 3 over 2. Yes? No, maybe? Alright. Going again. So let's just zoom out a little bit so we could speed up the thing. Alright, so that was 2015. I've gone real far. Alright. Okay, apparently I'm going straight to the end. Your partial 2016, 2017, were there any alpha beta questions? 2017 alpha beta. Alright, let me scroll back up to 2017. I know how this went so fast, boy. Oh, I want to do that inequalities question as well because I used to make an error with that. Right. Yeah, it is. All right. Let's do it quickly. All right. So 2x squared plus 6x plus 7 equals 0. A is equal to 2. B is equal to 6. C is equal to 7. All right. Alpha plus beta is equal to minus b over a, which is minus 6 over 2.